All right, so this is my Rust project, and uh, yeah, I'll just get into it. So, what this project is it's an n-body gravitational physics simulation, but also the bodies will like bounce off of the edges of the screen. It was just kind of a fun thing to do to learn Rust a bit better. So, walking through it up here on my imports. Here, I define the struct called a body. Now, a body is the body in the n-body simulation. Pretty straightforward. Here's the implementation. Draw, pretty straightforward. Just have Raylib draw handle, which is what I use to draw, I guess. And this just draws a circle at the position with the radius and yeah, the color of the thing. Then here we have update that every frame I update the position by the velocity. Here I set the bounce coefficient. Right now it's set to be perfectly elastic. Then here I get the screen width and height. And then here I just negate the velocity. I just reverse it if it hits that edge of the screen. So then I have this unused function to apply directional force, but that's not used, so that's whatever. Then here, my math functions. You should change this to math. So calculate dist. This calculates the distance between two vectors. So point A, point B, this just decomposes them, gets the difference. And then here, this is just Pythagorean theorem. So A squared plus B squared, and all of that square root to get C. Then here we calculate the angle between two vectors. This is just arctangent 2, which is pretty straightforward. This function is really more just a wrapper that decomposes the two vectors. Here we have the real meat of it, gravity, calculate gravity. Now this calculates the gravitational force as an F32 between two different bodies. So I just kind of made up this gravitational constant. This radius thing, I'll explain that in a second. So here, this is the gravitational equation. So gravitational constant times mass of the first thing times mass of the second divided by the distance between them squared. Now you'll notice exclusive clamp right here set to the negative radius and the radius. So that's just like the inside and the outside of the circle, I guess. Basically, exclusive clamp is just a thing I implemented for F32s that does the reverse of a normal clamp, meaning that you give it a minimum and a maximum, and instead of clamping within those values, it clamps without them, like outside of them. So the reason I did this is because before, the way I implemented it at first, when two things would like get close together, the distance between them becomes a small floating point number, and small floating point divided by small floating point equals a big floating point. So suddenly their velocities would be crazy high, maybe even overflow, and things would just vanish or be too fast to draw, and it just pinged all over and didn't look interesting. So this is just to guarantee that the maximum amount that gravity can act on them is the way that gravity acts when they're like just barely touching each other. So that's that. Now down here, actually before I come to this, I will show you my main function because these are all just things for my main function. So here, just some Raylib boilerplate. This makes the window. Ooh, I just realized I could change the size of the window. I forgot about that. So here, this is the mutable vector that holds all of the bodies for the in-body simulation. This is just a random number generator. This loop is what runs the logic every frame. So here you can just see I update every frame and I draw every frame. Now coming back up here, draw. This just hooks into the Raylib thing. It takes the bodies. So this just starts drawing. This clears the background to white. Otherwise, you get like, you just paint over the same buffer and like balls leave a trail. Looks kind of fun, but it's a little weird. So here, for each body, I just draw it wherever it is. So that's pretty straightforward, just graphics. Up here, the real meat and potatoes, update. So this takes the Raylib handle, the list or the vector of bodies, and the random number generator. So there is a thing in Rust called the borrow checker, which in another language like Python or Lua, where I've done things like this before, to do the gravity stuff, I would have a nested for loop where I go like, okay, for each body in all the bodies, I'm going to check each body that isn't this one. And then I'm going to do the gravity calculations and adjust the velocity and stuff to match, right? Problem is, Rust gets angry if you, well, it doesn't get angry. It more just is like, my sweet child, let me protect you from yourself. It stops you from having more than one mutable reference to an object at a time. So right here, you'll notice I'm iterating through all the bodies dot iter, as opposed to dot iter mut or mute or whatever, which is a mutable iter. So this is read only. But using this thing called a vec deck, which is just a deck implemented with a vec, I quite like the name. This is how I solved the problem. So for each thing, I do all the gravity math, but instead of changing the velocity, I calculate the net force for each body according to the gravity pulling on it from every other body. And then at the very end, once I processed each body's net force for all other bodies, I push that into the back of the body forces vec deck, right? So then next step after that, I just go through all of them. You'll notice this is iter mut. So this is editing the velocity. Here I go through, I pop each force off of the body forces vector or vec deck, and I apply it to each body. This is just like an error thing. It should never be triggered, but if it does, I've taken care of it. And then here, this just calls update on each one. That's the function I showed you up there. Just changes the position by the velocity. Now this is the interactivity part. So if the left mouse button is pressed, then within this range and within this mass, I'm going to randomly generate, or oh wait, within this velocity range, I'm going to randomly generate at the mouse's position a new body that will, yeah, it'll just have these things. Oh, and it also has a random color, which is quite pretty. As you can see here, I've made it slightly transparent. You'll see in a second. So this just starts this makes a new one that's a fun color heading in kind of a random direction with a random mass. So yeah, and now I will show you that in action. Just I'll go run. Behold, kind of a chunky one. Maybe we'll get something smaller. Yep, there we go. You can see, oh, this is a nice little orbit thing. Usually you don't get that nice of an interaction this early. But then if we add a third one, this is n squared. I'm not using like quad trees or anything, but I might in the future because that sounds fun to do. So it does get laggy once you get a whole bunch, but it can handle quite a few. Rust is a pretty fast, low-level language. Here, if you see that, that's kind of like a little conglomeration of them. Now these two will crash and it'll spew little chunks everywhere, like two planets colliding or something. I don't know. But yeah, making them transparent gives it a lovely pastel. Oh, you can see some slowdown. That's okay. You're doing great, little program. Maybe I should change the hello world. But yeah, that's the whole thing. Thanks for watching.